So I get a lot of people who tell me, you know, you can't teach a first grader chemistry and you can't teach a first grader physics. These are hard concepts and little kids can't learn these kinds of concepts. Well, I want to tell you a story about my daughter when she was 4, and I was doing a postdoc in Berkeley, and she came up to me one day and she said, "Mommy, what is a liquid?" Well, you know, she's in a scientific family, and this word liquid was kind of a technical word for her. And so I wanted to give her a real answer to her question. So I sat her down and I said, okay, you know, teaching moment that I have with my daughter. And I started to discuss with her the difference between solids, liquids, and gases. And I used water as an example, and I said, okay, liquid water is a liquid, but you know, water also exists as a solid, and you can heat it up and it will go into the vapor state. And so she's like nodding her head, okay. And I said, all right, so what is the difference between a solid, a liquid, and, you know, let's say a gas? And she, you know, I said, well, you know, basically the difference between ice water and liquid water and, you know, water vapor is just the molecular energy of the water molecules. And so these ice and water, liquid water and water vapor are all made of oxygen with 2 hydrogens, and that's a water molecule. And this oxygen and the 2 hydrogens are vibrating and moving around. And in a solid, it has low molecular energy, so they're not vibrating or moving around very much. And in fact, it's a lot like the adults at a potluck. You know, the adults are tired, they've been cooking all day, and they don't move around very much. And so a solid, it just is like the adults with low energy. So a solid are water molecules with low molecular energy. And she nods her head, okay. And so then I say, but a liquid is really the same thing as the solid. It's the same water molecules, they just have more energy. They're just moving around a little bit more. And so I was, you know, moving around in the room and showing her that, you know, I have a little bit more energy. And I said, you know, the liquid water molecules are a lot like the teenagers during a potluck. You know, they're moving around more, they're texting their friends, and they have more energy than the adults. And she nods her head and says, okay. And I said, okay, but a vapor or gas is really just water molecules moving with much more molecular energy. They're really moving around now. They're moving and they're hardly bumping into each other, and this is what makes a gas. And I said, you know, this is like the toddlers at a potluck. They're just zinging all over the place. They're moving here, they're moving there, you can't even pin them down. And so they just have more energy. And that's the difference between a solid, liquid, and a gas. And I stopped my lecture and I looked at her, and she sort of gave me the glassy-eyed look, and I thought, uh-oh, you know, I've gone over her head. I've told my 4-year-old about molecular energies. Maybe this was too complicated for her. And then she pauses for a minute and she says, well, so what is Jell-O? And I said, you know, I have to get back to you on that. I know it's not a gas, but I couldn't in the moment decide whether it was a solid or a liquid. So I called my husband up on the phone and I said, you know, hey, I was just telling our daughter about molecular energies. She asked this question about a liquid, and I was talking to her about molecular energies in solids, liquids, and gases. And she asked me what was Jell-O. And, you know, I know it's not a gas, but I'm not sure whether it's a solid or a liquid. And, of course, he's got his PhD in physics and chemistry, and I have my PhD in chemistry. And he said, you know, I have to get back to you on that. And that evening he came home and we spent several hours talking about shear stress forces and whether or not Jell-O was a solid or liquid. And by this time my youngest daughter is off doing something else. And so the point of this story is that not only was my 4-year-old able to understand conceptually what I was telling her, she understood it so well that she stumped the 2 PhDs in the family. And that's what told me real science for kids will work. I believe that if you give kids the real information, you present it in a way that's palatable for them, you present it in a way that they understand, but you don't water down the science. You maintain the integrity of the science when you present science to them. So one of the things that happens right now is kids take science classes, but they don't really get exposure to real chemistry and physics. And then when they get to high school, they have to take chemistry, physics, biology, you know, astronomy and geology, and these are the real hard classes. And in fact, the grades tend to drop off by the time they get into high school. The scores go down. Well, why is that? Well, we haven't really prepared our young kids, our elementary students and our middle school students to be able to take on chemistry and physics in high school. So I wrote Real Science for Kids Starting with kindergarten or first grade, my pre-level chemistry introduces very young students to the concepts of atoms and molecules and chemical reactions and acids and bases and polymers and DNA and protein. These are the subjects that a student will be exposed to, will have to learn in high school. And then in my level 1 series, I teach kids the same subjects, the same topics, atoms and molecules and chemical reactions and acids and bases and proteins and polymers. And the idea here is that learning science, in my opinion, is no different than learning a language or learning math or learning music. You must expose kids to the foundational building blocks for the subject that you want them to know. And so when we learn a language, we introduce kids to the alphabet and then to how to make words from the letters of the alphabet and how to put words together to make sentences and so on. We give them the building blocks of language. The same is true with math and music. And so why not do this for science? Why not give students the building blocks for real science, give them the chemistry, give them the physics, give them the biology, the real biology, which is really applied chemistry and physics to a living system. So now that they know the chemistry and physics, you can start talking about the chemistry and physics of living systems and biology, and then you can go on to discuss the chemistry and physics of non-living systems in geology and astronomy. And in my mind, this is the way to lay a solid foundation for science education in the elementary and mid-school grades. You give kids the real science, you give it to them in digestible pieces over the course of 8 years, and by the time they get to high school, chemistry and physics concepts, chemistry and physics vocabulary, and even some math is part of their toolbox. And they walk into a high school chemistry or physics classroom and they know this stuff. They've seen it since first grade. And so what I try to do is build this foundation for them so that they have a solid basis for understanding science before they get into high school and college. And this is what I wanted to accomplish with Real Science for Kids.